Hi, I'm Angelina Wang, and I will be presenting our work called Towards Intersectionality in Machine Learning, including more identities, handling underrepresentation, and performing evaluation, with my co-authors Vikram Ramaswamy and Olga Russakovsky. Intersectionality was first introduced as a term by Kimberly Crenshaw to capture the unique harms that Black women experience, on top of that from being Black or a woman. It broadly refers to how different identities along different axes interact to produce unique forms of discrimination. However, despite its prevalence and importance, intersectionality has not been picked up much in the machine learning fairness field. Our work considers the algorithmic effects of discrimination against demographic subgroups by conducting empirical studies of 5 fairness algorithms across a suite of 5 tabular datasets derived from the US Census. While most fairness work thus far has not incorporated intersectionality, instead assuming the relevant demographic groups are only along one axis and binary, there's also been a large rise in excellent work recently that does consider intersectionality. However, merely deciding to incorporate intersectionality is only the first step. In our work, we build upon this by engaging with the next steps that come up. There are many difficult considerations we need to keep in mind if we want to incorporate intersectionality in a meaningful way. Prior work has largely neglected these concerns, but there are substantive differences that set intersectionality apart from the multi-group setting and need to be considered. We begin by imagining a very simplified version of the machine learning pipeline with the steps of data collection, model training, and model evaluation. In terms of data collection, we will need to think about which identities are relevant to include in the task. If we include too many axes of identities and numbers of identities along each axis, then we risk having a computationally intractable problem. But if we include too few, we miss important intersectional differences in how different groups are treated. In model training, we need to consider how we can train a model when the various groups are likely to have a very small number of individuals as a result of having added additional axes of identity. And finally, in model evaluation, we need to think about how we will evaluate fairness on a large number of groups, since many of our existing fairness evaluation metrics are only designed for 2 groups, and the difference between them on some kind of performance metric. In this work, we concretely advise on how to address all 3 of these problems. For which identities to include, we find that a priori knowledge may be insufficient and recommend combining domain knowledge and empirical validation. Domain knowledge based on which identities are relevant for a particular downstream task is important, but also insufficient for understanding whether, for example, 2 groups happen to share similar input distributions for one particular domain and would actually benefit from being empirically treated as the same group rather than separated. For how to train a model when groups may have very small numbers of individuals due to the inclusion of more axes of identities, we first provide a warning that normative implications may disqualify certain existing techniques in machine learning. We instead suggest a potential alternative through leveraging structure in the data, such as that people in different groups, both shared identities, may share more features than those without shared identities. And finally, for evaluating fairness on a large number of groups, researchers frequently use different variations of pairwise comparisons, such as the difference in true positive rate between 2 groups. There are more than 2 groups, and the difference between the group with the highest and lowest true positive rate. However, all of these metrics look the same if you, for example, swap the labels of the subgroup labeled Black female and white male. This is surprising in the context of intersectionality, where the historical ways different groups have been treated is very important. Thus, we suggest using more deliberative contextual pairwise comparisons. We also offer incorporating additional evaluation metrics that are able to capture existing disparities in the data. These metrics measure the correlation between the ranking of groups for their positive labels in the datasets and the ranking of the groups for their true positive rates predicted by a model. Thank you for listening.